Okay, in this video, I want to show you how to use an augmented matrix in order to solve a 3-equation, 3 unknown. It's the elimination method. It's just using an augmented matrix to simplify your writing. You don't have to write a variable each time. And I'll just show you an augmented matrix. So an augmented matrix, we're going to use just like when we wrote matrix equations for inverse or multiplicative inverse equations. We wrote everything just using the coefficients of our variables, right? The coefficients, the numbers in front of the variable. So this equation be written 1, -2, 1, and 7. And what I'm going to do is just put a dash here to indicate that that 7's on the other side of the equal to sign. So for this one, it is 3, 1, -1, 2. And for my third and final equation there, it's 2, 3, 2, and 7. All right, so I'm going to show you a method in just one example here, but these work for all of them. We're going to have a plan of attack. And our plan of attack is that we always want to cancel this term out first. We want to make that a 0. So that's step 1. Step 2 is we want to make this one a 0. And then because we have a 0 on top of a 0, it's going to make the rest of the equation become really easy. And our third plan of attack then would be obviously to make this one 0. So we have a plan of attack set in place. So I'm just going to rewrite this so I don't have another mess. These, doing it this way, can become very tedious if you don't have a plan. And you're very prone to making mistakes if you don't have a plan. So that's why we're always going to stick to this plan regardless of how easy it might be a different way. For me anyway, I always stick to this plan where I cancel here, or I get that to be a 0, this one to be a 0, and this one to be 0. So I'm just going to go ahead and copy this over so I don't get confused about some of the drawing and think a number is a different number. So 3, 1, -1, 2, 2, 3, 2, and 7. Okay, so because we have a plan of attack, we're going to cancel out this. We're going to make that a 0 first. To make this a 0, I can multiply either this one or this one by anything, or I can use the top equation if I want to. I can use that top equation and cancel out. All we have to decide is what two equations we want to use, and then we're going to multiply them by something to get them to cancel out, and then we're going to rewrite. Before I do anything, I want to rewrite the lines that I don't want to change. I don't want this one to change, and I don't want that one to change. So I want that still in my next step to be 1, -2, 1, and 7. And for row 2, I still want it to be 3, 1, not -1, 1, and -1, and 2. I still want that. The only thing I want to change is this row right here. We know that I can multiply this. If I multiply this whole row and this whole row to get the top two 6 and one -6, and when I add down, they'll cancel out. So if I multiply each of these by -3, so I would get -6, -9, -6, -21. And if I multiply each of these by 2, I would get 6, 2, -2, and then 4. Now when I add down, you see when I add down here, I'm going to get these, this row is going to become a 0. So I'm going to write that over here in my new, this is going to be 0. When I add -2 and -9, or that should be a +2, sorry. I see, I thought my dash was a negative. +2 and -9 should be 7. And then when I add -2 and -6, I get -8. And -21 and a +4, and I add those together, I get -17. Keeping with my plan of attack now, we want to make this number become a 0. That's 3. So again, I'm going to rewrite anything that I want to keep the same. I want row number 1 to be the same. And I want row number 3 to be the same. I don't want those to change at all. And what we're going to do is we're going to change the middle term. So if I look, I can use the first and I can use the second equation to get that number to cancel out. If I multiply each of these by a -3, +6, -3, and negative 21. And now add the first one and the middle one together. I get this term in the red here to cancel out. So negative 3 plus 3 is 0. 6 plus 1 is 7. Negative 3 plus negative 1 is negative 4. And negative 21 plus 2 is negative 19. So now what I've accomplished is I've gotten this zeros on top of a 0. And why that's important is if say something would cancel out in this and this one. Say if I added down, say that these terms are both 2's. When I add them together, I got a 0. I'd be going around in circles because when I add this term, this and this, 1 plus 0 is 1, so then I get a 1 in that spot again. So the objective is to get a 0 on top of a 0, and then now we can use the two equations that we have zeros in, these two equations, to cancel out another one. So we're going to stick with our plan of attack, and we're going to cancel out that middle term. Okay. And I think this was a negative 7, by the way. I missed a negative sign in there earlier. Hopefully you guys are probably watching this video and screaming at me saying that I missed a negative sign. But I missed a when I was way up here. 2 plus a negative 9 is negative 7. That's where that is. All right. Now what I've noticed now is that these two, if I add them together already, they will cancel out. They'll become 0. So let's go ahead. We don't have to multiply any of them by anything. But before I add down, I want to rewrite the ones I don't want to change. I don't want the top to change, and I don't want the middle to change. Now, when I add down, 0 plus 0 is obviously 0. 7 plus a negative 7 is 0. And then negative 4 plus negative 8 is negative 12. And then negative 19 plus negative 17 is negative 36. So now what I've accomplished, if you can remember way back to the start, you remember these first columns, these were all my x values. These are all the coefficients for my y values. These are all my z's in this term, x, y, and z. And these are all after my equal to sign, these were. So what this is telling us is it's telling us we have negative 12z equals negative 36. So we know how to solve that. We divide by negative 12, divide by negative 12, and z equals 3. Why this is nice is because the next one falls apart. We know what z is. This next equation reads 7y minus 4z equals negative 19. Well, I already know what z is, so let's plug it in. So I have 7y minus 4 times 3, because that's what z is, equals negative 19. 7y minus 12 equals negative 19. Add 12, add 12. 7y equals negative 7. Y equals negative 1. So far I found z and I found y. I can go back up to my third equation then. If I know z and y, I can solve for x. I'm running out of room on my board, but I know I have 1x. That's what this reads. 1x minus negative 2y, 1z equals 7. So I have 1x minus 2 times y, but we know that y is negative 1. And then plus 1z, we know z is 3, equals 7. Negative 2 times a negative 1 is a positive 2, so I have x plus 2 plus 3 equals 7. X plus 5 equals 7. Subtract x equals 2. So when they asked us originally to solve for x, y, and z, x equals 2, y equals negative 1, and z equals 3. So we found where these three equations with three unknowns intersect. I hope this helps. We'll see you in class.